I welcome you back to this Christmas edition of Formulae, Stoichiometry and Mole concepts. We had covered the Roman one. We had covered Roman one, which was on finding molecules of ethylene. So Roman 2, we want to determine number of atoms present in ethylene gas formed. Therefore, to find the number of atoms present in ethylene gas which is formed, we have, this is item 9 Roman 2. So we are given the item provides us with the mass of, I think it is mass of ethanol. So we use it to find moles of ethanol, then moles of ethylene, and the number of atoms of carbon. Number of atoms of carbon, but having it in mind from what we have seen from item 9, one ethylene molecule, if you look at this molecule carefully, it has 2 carbon atoms. It also has 4 hydrogen atoms. So one ethylene molecule has 2 carbon atoms. It as well has 4 hydrogen atoms. So we must find number of carbon atoms and then find number of hydrogen atoms independently. Yes, carbon atoms and hydrogen atoms independently, their number. So in this case, the pathway has been simplified because from Roman 1, we have now moles of ethylene. We have them. We have seen how moles of ethylene were obtained from Roman 1. We do not need to go through the same steps because it is still the same item, but item 9 Roman 2. So we use the previous moles. They are the same. They will be the same moles. So 1 mole of ethylene, so we are starting with carbon atom. With carbon atoms, 1 mole of ethylene has 2 moles of carbon atoms. That is, 1 mole of ethylene is equal to, for each mole of ethylene, you have 2 moles of carbon atoms. Then what of the 5 moles? The 5 moles will equal to 2 times 5, and this gives us 10 moles of carbon atoms. 10 moles of carbon atoms. Now, these are moles of carbon atoms. I use them to find number of atoms of carbon. So 1 mole, to find number of carbon atoms, their number, because these are moles, we use the fact that 1 mole of carbon atoms is equal to 6.02 times 10 power 23 atoms. Then what of the 10 moles? The 10 moles will equal to 10 times 6.02 times 10 power 23, and this gives us 6.02 times 10 power 24 atoms of carbon. That is, if we calculate this. Then next we proceed with moles of hydrogen atoms. For moles of hydrogen atoms, we have the same pathway, having it in mind that 1 mole, 1 ethylene molecule, 1 ethylene has what? 1 ethylene has 2 carbon atoms, and it also has 4 hydrogen atoms. From this formula, there are 2 carbon atoms and 4 hydrogen atoms. So we have seen already the number of carbon atoms. We have calculated them. So in this case, we are interested with hydrogen atoms. So what shall we do? We shall have moles of ethylene have been calculated as 5 moles. So 1 mole of ethylene is equal to 4 moles of hydrogen atoms. There are 4 moles. For each 1 mole of ethylene, you have 4 moles of hydrogen atoms. Then what of the 5 moles? The 5 moles will now give us 4 times 5, and this gives us 20 moles of hydrogen atoms. So we use this to find number of atoms, and to find number of atoms, we use the Avogadro's relation. 1 mole of hydrogen atoms is equal to 6.02 times 10 power 23. Then what of the 20 moles which have been obtained? We shall have 20 times 6.02 times 10 power 23 atoms. And computing this, we obtain 0.205 times 10 power 25 atoms of hydrogen. So this is item 9, Roman 2. Allow me first